Problem 16. In a middle school mentoring program, a number of 6th grades are paired with a 9th grade student as a buddy. No 9th grader is assigned more than one 6th grade buddy. If 1/3 of all the 9th grade are paired with 1/3 of all the 6th graders, which fraction of the total number of 6th and 9th graders have a buddy? So we have 1/3 of the 9th grader is equal to 2/5 of the 6th grader. 6th grader, and so for n equals and assume s equals 5, then n equals 6. So 1/3 of 6 equals 2, and 2/5 of s also equals 2. And say a total of 2 plus 2 students have buddy equals 4 equals as buddy, and the total number is 5 plus 6 equals 11. So 4 out of 11 has a buddy. Problem 17. Jeremy's father drives him to school in rush hour traffic in 20 minutes. One day there's no traffic, so his father can drive him 18 miles per hour faster and getting to the school in 12 minutes. How far in mile is it to school? So we use a table rate, time, and the distance. In rush hour in 20 minutes, assume the rate is x. 20 minutes is 1/3 hour. The distance is 1/3 x. Here no traffic. Drove to school in 12 minutes. 12 minutes is 12 out of 60 equals 1/5 hour. 18 miles faster. And this is the same distance, so those could be equaled. And common denominator is 15, so multiply 15 on both sides. Backfill the number. So everything works out. How far in miles get to school? So that's 9. Problem 18. An arithmetic sequence is a sequence in which each term after first is obtained by adding a constant to the previous term. For example, 2, 5, 8, 11, 14 is an arithmetic sequence with 5 terms, in which the first term is 2 and the constant added is 3. Each row and each column in this 5 by 5 array is an arithmetic sequence with 5 terms. The sequence in the center is labeled x, as shown. What is the value of x? So in an arithmetic sequence, the middle number is the median, and it's also the mean. It's also the mid-range, which is minimum plus max divided by 2. So here, the center number is 1 plus 25 over 2 equals 13. And this number is 17 plus 81 divided by 2. Divided by 2 equals 49. And x is equal to 13 plus 19 divided by 2 equals 49, and 1263 divided by 2 equals 31. So answer is B. Problem 19. A triangle with vertices as A equals 1, 3, B equals 5, 1, C equals 4, 4 is plotted on a 6 by 5 grid. What fraction of the grid is covered by the triangle? So if we draw a rectangle which just is tangent to this triangle, and this corner is 1 by 3, 1 by 3, this is 2 by 4. So the inner triangle is 3 by 4 minus 1/2, 1 minus multiply 3, minus 1/2, 1 multiply 3, minus 1/2, 2 by 4 equals 12, minus 2 thirds, 1.5 and minus 3/2 minus 4 equals 12 minus 3 minus 4 equals 5. So the triangle area is equal to 5, and the total area is 5 by 6. 5 over 5 by 6 equals 1/6. Problem 20. Ralph went to a store and bought 12 pairs of socks for a total of $24. Some of the socks he bought cost $1 a pair. Some of the socks he bought cost $3 a pair, and some of the socks he bought cost $4 a pair. If he bought at least one pair of each type, how many pairs of $1 sock did Ralph buy? So if assume X is $1 sock and Y is the $3 sock and Z is the $4 sock, so we have 12, and then X plus 3Y plus 4Z equals 24. And we also have conditions that X, Y, and Z are all greater equal than 1, and they are all integer. So this is 1, this is 2, and 2 minus 1, we will get 2y plus 3z equals 12. And so let's try z from 1. So if z equals 1, then 2y equals 9, that won't work. And z equals 2, then this is equals 6. And 2y equals 6, y equals 3. So that's a valid case. And if z equals 3, that's 9, and it won't work. And if z equals 4, then that will be 0, and that's not allowed. So the only possible way is z equals 2 and y equals 3. And then x has to be 7. How many one pair $1? So that's 7. Problem 21. In the given figure, hexagon ABCDEF is equiangular. ABJI and FEHG are squares with areas 1 and 32 respectively. Triangle JBK is equilateral, and FE is equal to BC. What is the area of the triangle KBC? So these are square. This will be equal, and this is square. It's going to be equal, and this is equilateral triangle. It's going to be equal, and this hexagon is equiangular, so each angle is 120. And for this corner, 120 and 90 and 60, and the remaining angle has to be 90. And because this square is 18, so each side is 18 square root equals 3 square root of 2. And this is, each side will be square root of 32 equals 4 square root of 2. So this is 4 square root of 2, and this side is going to be 3 square root of 2 with the right angle. The area of the triangle is 1/2. 3 square root of 2 multiplied 4 square root of 2 equals, this will cancel out, will be 12. Area 12. Problem 22. On June 1st, a group of students are standing in rows with 15 students in each row. On June 2nd, the same group is standing with all the students in one long row. On June 3rd, the same group is standing with just one person in each row. On June 4th, the same group standing with 6 students in each row. The process continues through June 12th with a different number of students per row each day. However, on June 13th, we cannot find a new way of organizing the students. What is the smallest possible number of the students in the group? So basically, the total of the number of students could be factored by 12 ways. And we know one of the factors is 15. 15 equals 3 multiplied 5. And 6 is 2 multiplied 3. And so it's 2i and 3j and 5k. So the size of the student group is in this format. And so if I equals 2 and j equals 1 and k equals 1, we have 2 square multiplied 3 multiplied 5. That is 3 by 2 by 2. Altogether have 12 ways of factoring. So this is 60. That's the smallest possible number in students. Problem 23. Tom has 12 slips of paper which he wants to put into 5 cups labels A, B, C, D, E. He wants the sum of the number on the slip in each group to be an integer. Furthermore, he wants 5 integers to be consecutive and increase from A to E. The number on the paper are 2, 2, 2, and 2.5, 2.5, 3, 3, 3, 3, 3.5, 4, and 4.5. If a slip with 2 goes into cup E and slip with 3 goes into cup B, then the slip with 3.5 must go into a cup. So we are going to draw, this is A, B, C, D, E, and label 2 goes here, and 3 goes here, and altogether we have 2 multiplied 3 plus 2.5 multiplied 2 plus 3 multiplied 4 plus 3.5 plus 4 and plus 4.5. This is 12. This is 12. This is 5, 6. This is 24, 30, 35. 35 is the total number. Average of 35 is 7. So this is 7, 8, 9, 6, and 5. To make the integer, so we have 2.5 and 2.5 and 3.5 and 4.5. They need to pair with each other. 3.5 need to pair with either 4.5 or 2.5, and they have to be two groups. Otherwise, if a single group, that's 5 plus 8 equals 13, bigger than anyone, they have to become two pair. So if 3.5 is paired with 4.5, it has to go here because that's 8. 7 position and 9 position is leftover number is 7, cannot host it. So that's if it pair with 4.5, it has to go here. And if it pair with 2.5, then it will add up to 6. And it still need to go here because this 6 is occupied. I cannot go into 7 and 9 because I don't have a 1 to pass that number up. So if it pair with either 4.5, it goes here. And if it pair with 2.5, it still goes here. So that's why has to be D. Problem 24. A baseball league consists of 214 divisions. Each team plays every other team in its division in games. Each team plays every team in other division M games with N greater than 2M and M greater than 4. Each team plays a 76 game schedule. How many games does a team play within its own division? So in its division N games, and N is greater than 2M, and M is greater than 4. And so the total gain is actually in its division. There are 14 in each division, 1, 2, 3, 4, and the other division is 1, 2, 3, 4. And within each division, one team can play with 3 other teams. So it's 3. So it's 3M plus when it play other team, it can play 4 games. Equals 76. And let's assume M equals 2m plus k, and k is need to be greater than equals than 1, and so here is 2m plus k plus 4m equals 76. 6m plus 3k plus 4m equals 76. 10m plus 3k equals 76. M is greater than 4. Greater, not greater, equal. Greater than 4, so M can try 5, 6, and 7. If M is 5, and then 3k is 26, that do not work. If M is 6, 3k equals 16, that also do not work. If M equals 7, then 3k equals 6, k equals 2. So M equals 7 and N equals 2 multiply 7 plus 2 equals 16. And with its own league, it's 3 multiply 16 equals 48. And between the league, it's 4 multiply 7 equals 28. They add up to 76, so everything clicks. One inch square are cut from the corner of this 5-inch square. What is the area in square inch of the largest square that can fit into the remaining space? If we link with the center, then actually it's a bigger. This triangle connecting tip of the corner is 3 by 3 equals 9. If we put the middle point of it's going to be bigger than this one. It's going to be 5 multiply 5 divided by 2 equals 12.5. So if we slide this around this corner until it's tangent to the corner, it's going to be even bigger. So the triangle, the area of this A, B, C, D is equal to the inner square, that's 3 multiply 3, plus the area of the 4 little triangle. And each triangle Each triangle is 1/2 of the area of the corner rectangle, and this is 1/3. 1 multiply 3, so each pink area is 1/2 of equals 1.5. So it's 3 multiply 3 plus 4 multiply 1.5 equals 9 plus 6 equals 15.